Bismillahirrahmanirrahim. Assalamu alaikum dear students, welcome back to new video. Today we have to solve question number 5 of the chapter number 22, question number problem number 7 from the chapter number 22 of the Halliday, RESNICK and Walker Fundamentals of Physics 10th edition. The video is only for the educational purpose, it is not for any commercial use. Question is, in the figure given, the four particles form a square of edge length 5 cm. A is 5 cm here, and have charges Q1 is plus 10 Newton nanocoulomb, Q2 is minus 20 nanocoulomb, and Q3 is equal to plus 20 nanocoulomb, and Q4 is minus 10 nanocoulomb. In unit vector notation, what net electric field do the particles produce at the square centers? स्क्वायर के सेंटर पर यहाँ पर इनकी वजह से जो नेट फील्ड पैदा हो रही है वो कितनी होगी। पहले हमें समझ लेना चाहिए कि चूँकि Q1 पॉजिटिव चार्ज है तो इसकी फील्ड विल बी डायरेक्टेड आउटवर्ड फ्रॉम द Q1, सो इट विल बी डायरेक्टेड टुवर्ड्स द सेंटर O. Okay, let's suppose O is the center of the origin. Similarly, Q2 is negative charge, so its field will be directed towards Q2 in this direction. Arrowhead shows the direction. And similarly, Q3 is again positive, so its field will be directed away from Q3, means it will be directed towards O. And O4 is also negative, Q4 is negative, so E4 will also be directed towards Q4. It means it will be away from the towards Q4 are away from the center O of the origin square. So when you have to find the net field, it is easy to calculate the net field of Q1 and Q3 because they are opposite to each other and in the same line. So if we subtract from the smaller unit from the bigger vector, then we get the net force from the E3 and E4. And similarly, E4 and E2 are also in the same line and opposite in direction, so the difference of E2 and E4, the difference vector of E2 and E4 will be the magnitude, will be the net force of net electric field from Q2 and Q4. For magnitude, we just subtract the magnitudes. Okay, now each length is A, therefore if we form a rectangle triangle here, this triangle Q4, Q3 and Q2 taking as the vertices of the triangle, then this side is A, this side is A, and also the angle here, this angle is 90 degrees, it means this is hypotenuse, this is base, and this is perpendicular. So base square is A square plus A square should be equal to the, let this length is L, it is equal to L square. Okay, now if you simplify it, then we can find that A square plus A square is 2, so A square is equal to L square, or L is equal to under root of this, which is equal to 2 under root into A square under root A, so L is equal to under root 2A. So this diagonal length, this diagonal also, because it's square, so both diagonals are equal in length, so both diagonals have the length of under root 2 into A. Now the distance from the center of the origin of the square from the each charge will be half of this L and Y. I say that this is R, and R should be equal to L over 2, so L over 2 will be equal to under root 2 A over 2, which can be written as A over under root 2. So this is the information which you will have to use. Similarly, the given data is A is given as 5 centimeters, so it is 5 into 10 to the power minus 2 meters. Q1 is 10 nanocoulomb, so it will be 10 into 10 to the power minus 9 coulomb. Q2 is minus 20 nanocoulomb, so it will be minus 20 into 10 to the power minus 9 coulomb. Q3 is 20 nanocoulomb again, so it can be as 20 into 10 to the power minus 9 coulomb. And Q4 is again minus 10 nanocoulomb, so it is minus 10 into 10 to the minus 9 coulomb. Now we found first as I explained the figure, E1 will be equal to the electric field due to Q1, its magnitude will be E1, and is equal to 1 over 4 pi epsilon naught into, because the point charge, so electric field to point charge is equal to q1 over r square into 1 over 4 pi epsilon naught. So I will use the only magnitude of q1, though I will discard the sign. Sign will be used to check the direction of the field, which I have already discussed with you. So putting the values, 1 over 4 pi epsilon naught is 8.99 into 10 to the power 9, and q1 is given as 10 into 10 to the power minus 9 coulomb, and r is a over under root 2, so r square will equal a square over 2. Now simplify it. They look here, this is 10 to the power 9, this is 10 to the power minus, so they have cancelled each other. Okay, so we are left with 8.99 into 10. 8.9 into 10 is 89.9, and this 2 in the denominator will be multiplied to the numerator of the fraction. So we will write 2 into 89.9 over, putting the value of a is 5 into 10 to the power minus 2 meters. So a square will equal to 5 into 10 to the power minus 2 whole square. When we simplify it with the help of calculator, or manually you will do it, the answer comes out to be 7.192 into 10 to the power 4. So this is it is in our editing in SI unit, and SI unit of field is Newton per Coulomb. So the E1's magnitude, the field due to Q1 at the center of the square as will be equal to 7.192 into 10 to the power 4 Newton per Coulomb. Now similarly, look here, the field due to Q3 is E3, and this will be equal to 1 over 4 pi epsilon naught Q3 magnitude over r square. R is given as a over 2 under root. So putting similarly as we did in the for E1, plugging in the values and simplifying, we get the value of E3 as 14.384 into 10 to the power 4 Newton per Coulomb. It is exactly double of the E1, because charge is double of the Q1, and they are at the same distance. Now let's suppose that the E3 comma 1 is the net field or the electric field of Q1 and Q3. Look here, E1 is towards the U and E3 also towards U, but they are in opposite direction, so they will cancel each other. Okay, therefore E31 will be its magnitude can be calculated as the subtracting the magnitude of E1 from the E3. So putting the values, we can get the magnitude of so the net force, net electric field due to Q3 and Q1, its magnitude will be E3 minus E1, and it is very obvious that their E3 is 14.384 and E1 is 7.192. When we subtract it, they are double of each other, so that it comes out to be 7.192 into 10 raised to the power 4 Newton per Coulomb. So what will be its direction? Look here, because E3 is bigger than in magnitude than the E1, and they are opposite in direction, so the net field will be in the direction of E3, and E3 is here along the diagonal. Now each angle of the square is 90 degrees, or diagonal diagonal bisect the angle, so each side angle the diagonal make with the side, each side will be 45. Now it is very obvious that this angle is 45 from here to here, and this is 90 because because angle of the square is 90, and this is straight line. This is inside the angle, interior angle is 90, or exterior also 90. So 90 plus 45 is 135. So E3 will make an angle of 135 with the x-axis. As we take the clockwise anti-clockwise angle, it makes with the x-axis at the tail. Okay, so its angle will be 135 with the x-axis. So the net force will be equal to, due to Q3 and Q1, will be equal to 7.192 into 10 raised to the power 4 Newton per Coulomb at 135 to the x-axis. When you know the angle with x-axis, you can find the x component of vector as the magnitude of vector into cos of the angle mixed with the x-axis. It's x component. So magnitude of the E31, the net force, net electric field due to the Q1 and Q3 is 7.192 in terms of force magnitude into cos of 135. Cos of 135 is nothing but minus cos of 45, but you can do it with the help of calculator. When you simplify it, it comes out to be minus 5.08 in terms of 4 Newton per Coulomb. Similarly, the y component of the net electric field due to Q1 and Q3 will be equal to 7.192 in terms of 4 into sine 135. When simplified, it comes to plus 5.08 in terms of 4 Newton per Coulomb. So this is x component and y component. If you want to find, write it in the x and y component form, unit vector notation, you can write as the E31 in vector form equal to minus 5.08 in 10 power 4 Newton per Coulomb I plus 5.08 in 10 power 4 Newton per Coulomb J. It is not necessary to write because they only asked for the resultant of all four vector fields, so we no need to write it. Okay, if you write it is okay. Now similarly, we want to find the electric field due to Q2 at center, that will be equal to E2, and that will be equal to 1/4 pi epsilon naught into Q2 magnitude in over R square. Putting in the values, again R is same, A over 2 under root, so R square equal to A square over 2 under root, 2 under root square will be A square over 2, and 1/4 pi epsilon naught is 8.99 10 to the power 9. Q2 magnitude is 20 10 to the power 9 minus 9 because nanocoulomb. They are cancelled, which is the 10 power plus 9 and minus 9 cancelled. So we left with the 8.99 into 20 over A square over 2. Putting in the values and simplifying it, we get the value of E2 again as 14.384 in 10 power 4 Newton per Coulomb. This is E2, and its direction has been already discussed in the figure. You can see it in the figure. Okay. Similarly, the electric field due to Q4 will be equal to E4, and S is equal to 1/4 pi epsilon naught into Q4 magnitude over R square. Putting in the values and simplifying, we get it to be the 7.192 into 10 to the power 4 Newton per Coulomb. Now let's again take a look of the figure of the diagram given in the questions, so that you can figure out the E2 and E4. E2 and E4 are in the same line but in opposite direction, so they will cancel each other, so the resultant magnitude will be equal to E2 minus E4 because E2 is bigger. Now E2 is directed, so E2 is directed towards Q2 away from O, and E34 is directed towards Q4 away from O, so they cancel each other. The resultant will be E4 E2 minus E4 because E2 is bigger, so the resultant direction will be in direction of E2, that is towards Q2. So it will be from, if we draw it here, so E4 to resultant will be from here to Q2 along this diagonal. So it's the angle it makes with the x-axis will be equal to 45 degree. So its direction will be at 45 degree along the diagonal, at 45 degree with the x-axis. Okay, so we use this angle to find the x and y component of the resultant of E4 and E2. E42 will be equal to E2 minus E4, and it will be in the direction at the angle 45 degree to the x-axis. At 45 degree to the x-axis. Now we find the components of the E24, the resultant of 4 and 2. X component will be equal to the magnitude of the resultant into cos of 45, which comes out to be 5.08 Newton per 4 Newton per Coulomb. Similarly, y component of the E42 comes out to be 5.08 Newton per 4 Newton per Coulomb. Now we have all the x vectors, x and components, become two vectors, left with two vectors, E31, the resultant of E3 and E1, and E42, which is the resultant of E4 and E2. They are two vectors which have to be added to find the resultant, overall resultant. Okay, the net force, the net electric field of the due to four charges. So let's suppose that E is be the resultant field of all the four charges. Then E can be written as EXI plus EYJ. Now Ex is x component resultant is equal to the sum of the x component of the vectors to be added. So E3 x component we have already calculated. E4 to x component also we have calculated. We add them, and E3 1 x component is minus 5.08 into 10 raised to power 4 Newton per coulomb, and E4 2 x component is 5.8 plus 5.08 into 10 power 4 Newton per coulomb. They are opposite signs but equal, so they cancel each other. So net force is equal to 0. So x component of the resultant will be equal to 0. Now y component. When x component is 0, it means the resultant will be only equal to Eyj. No need for x component now. Ey is equal to the y component of the resultant is equal to the y component of the 3-1 and the y component of the 4-2. We have already calculated, just put in the values, add them, they are equal and also have the same sign in the same direction, so they will be added, and when you add them it comes over 10.16 into 10 per 4 Newton per coulomb. In scientific notation, we have to move this decimal point here after 0, so we have to move one digit toward left, so this 10 power 4 will become 10.5, because when we move decimal digit to the left side the power of 10 is added. So we have to move one digit, so 1 is added to 4, 4 power 1 is 5, so it becomes 1.016 into 10 power 5 Newton per coulomb, which can be rounded off to 1.02 into 10 power 5 Newton per coulomb, the y component, Ey. So because we know that E is equal to Ex plus Eyj, so put in the values. Since Ex is 0, no need for writing it, so it will be, we just need y component, and y component 1.02 into 10 per 5 Newton per coulomb, so E will be equal to 1.02 into 10 per 5 Newton per coulomb. J the unit vector because it is in the y direction. That's it. So that's the answer of the question. So we have calculated the net force due to the four charges along with the given magnitude and signs located at the four corners of a square of edge 5 centimeter. That's all from today. I hope you like it. If you have any queries, you can ask me in the comment section. I will respond to it. So stay tuned to Believe Physics. Inshallah, I will upload new videos very soon. Until then, Allah Hafiz. Take care. Bye bye. Good night.